In this video, we're going to go over section 10.3 from our textbook, which is on more trig identities. We're going to look at double angle and half angle identities. And so we're just going to do several examples working with these identities here. And as you can see, these are our double angle identities. We have cosine of 2a, so double our angle a. It's going to be given by this guy here, and this is an alternative form. Similarly, sine of a double angle a is given by this, and alternatively can be written in this form. This is a typo here. So this should be sine of 2a there. And lastly, tangent of 2a is given by this here. And the way that we find these identities here, we'll just do this first one, cosine of 2a. So this is the same as cosine of a plus a. And we know from the last video when we had the sum and difference identities that this guy here is going to be the sum identity for cosine. This is going to be cosine of a times cosine of a minus sine a times sine a. This gives us cosine squared a minus sine squared a, which is exactly what we have for our double angle identity here. And then the rest of these identities can be verified in a similar way. So let's look at this example here. We're told that sine theta is equal to minus 13 over 85. Cosine theta is going to be some value that's less than 0. And what we want to do is determine the values of our sine and cosine functions for a double angle. Okay, so first, notice that sine of a double angle is going to be 2 times sine of that angle times cosine of that angle. Now we do have sine of this angle, but we don't have cosine of this angle. So what we're going to need to do first is find cosine of this angle. And in this case, we're looking at angle theta versus angle A, but same idea. So what we'll do here is we'll use one of the Pythagorean identities and this guy here to find cosine theta. So we'll use the fact that sine squared theta plus cosine squared theta is equal to 1. Now what we'll do here is we'll plug in what we know for sine theta. Since sine theta is equal to this here, sine squared theta is going to be equal to this guy squared. So we have negative 13 over 85 squared plus cosine squared theta is going to be equal to 1. Now this guy here is going to be positive since we're squaring it. 13 squared is going to be 169, and 85 squared is going to be 7,225. So we'll have that fraction, and if I were to subtract that fraction on both sides, we'll get cosine squared theta alone. We'll get cosine squared theta is equal to 1 minus 169 over 7,225. Now, what we'll do is simplify the right-hand side. And we'll do that by getting a common denominator so we can subtract these two guys, which results in this here. Now, subtracting these guys gives us 7,056 still over this common denominator. Now, what we want, remember, is we just want cosine theta. So what we'll do is we'll square root both sides of our equation. And we'll get cosine theta by itself. Now, to square root these guys, we can look at the square root of the numerator over the square root of our denominator. This will give us, remember, since we're taking the square root, this will give us plus or minus. Square root of the numerator is going to be 84, and the square root of the denominator we know is going to be 85. Now, remember in the beginning of the example, it told us that cosine of this value theta needs to be less than 0. We just showed that cosine of this value theta is either going to be plus or minus this guy. Since it needs to be less than 0, this tells us cosine theta is going to be minus 84 over 85. Okay, so now we know cosine theta and we know sine theta. We can plug those values into this identity here to get sine of this double angle. So this tells us sine of 2 theta is going to be equal to 2 times sine of theta, which we'll just plug in. So that'll be negative 13 over 85 times what we got for cosine theta, which is negative 84 over 85. Okay. Now multiplying these guys, we'll get a positive number for these two fractions. We get this here, and then multiplying the numerator by 2, we'll get this here. And we can't simplify this fraction further, but that's fine. This will just be the value for sine of this double angle. Now, we also want to find cosine of this double angle. Going back to our formula here, that's going to be cosine squared of this angle minus sine squared of this angle. And we have that information, so we can plug it right in. Cosine squared of this angle is just going to be cosine of this angle squared. So this will be negative 84 over 85 squared. And then sine squared of this angle is just going to be sine of this angle squared. So this gives us this here minus this here. Now subtracting these guys, we'll get this over our common denominator. And we can't simplify this guy further either, so this will be our final answer. So that's how we'd use our identities to find the double angles for sine and cosine, given just this information. Okay, let's look at another example here. In this case, we're given these three expressions here, and we want to evaluate them. The first thing that we want to do is recognize if these are any identities. So let's look at A here. Notice that this is the same identity for the double angle for a cosine function. Cosine of 2 theta is equal to cosine squared theta minus sine squared theta. Now, in this case, we have exactly that here, and theta is equal to pi over 12. So what we can do is evaluate this. We know that this is going to be equal to cosine of 2 theta. We know theta is pi over 12. So simplifying this, we'll get cosine of pi over 6, which, referring to our unit circle, we know is going to be root 3 over 2. All right, let's look at this next example here. We have 4 times sine of pi over 3 times cosine of pi over 3. Now this kind of looks like the double angle for a sine function. Remember, this guy is going to be sine of 2 theta is equal to 2 times sine theta times cosine theta. This looks very similar. The only thing is that this coefficient in front of this guy is actually 4 rather than 2. So we can manipulate our identity and multiply by 2 on both sides. What we'll get here is that 2 sine of 2 theta is going to be equal to 4 sine theta times cosine theta, which is exactly of this form here. And in this case, theta is going to be equal to pi over 3. Alright, so if we know that this will be equal to pi over 3, or theta will be equal to pi over 3, we can just plug this in to this guy here. This gives us 2 times sine of 2 pi over 3. Now 2 pi over 3 is just going to be root 3 over 2, referring to our unit circle. The 2's cancel, and this gives us square root 3. And then lastly, we're looking at this expression now. Now this guy kind of looks like the formula for the double angle for tangent. That guy is tangent of 2 theta is equal to 2 times tangent of theta over 1 minus tangent squared theta. Now referring back to this expression, that's exactly what we have here, but in this case, theta is going to be equal to 15 degrees. So what we'll do here is evaluate this guy using the fact that theta is equal to 15 degrees. We have tangent of 2 times 15 degrees. That's what this is equal to. This will be tangent of 30 degrees, just multiplying those guys. And we know that tangent of 30 degrees is going to be the value of sine of 30 degrees divided by cosine of 30 degrees. And remember, 30 degrees is the same as pi over 3. So referring to our unit circle, sine of pi over 3 is going to be 1/2, and cosine of pi over 3 is going to be the square root of 3 over 2. This gives us, what we'll do is we'll multiply by the reciprocal of this guy, so our 2's will cancel, and we'll be left with 1 over the square root of 3. It's always a good idea to rationalize these denominators. Doing so, we'll just multiply by the square root of 3 to the top and bottom of this fraction, and this will give us square root of 3 over 3. So that's how we would evaluate expressions of the form of our double angle identities here. And I just realized for this example here, I said tangent of 30 degrees is pi over 3, but actually tangent of 30 degrees is going to be tangent of pi over 6. So I just wanted to make that clear. Sine of pi over 6 is going to be 1/2, and cosine of pi over 6 is going to be root 3 over 2. Okay, so let's move on to half angle identities. That is given by these guys here. So if we had an angle A, cosine of half of A is going to be given by plus or minus of this guy here. And the sine of this guy is going to be determined by the quadrant of our half angle here. And same for this case with sine of our half angle and tangent of our half angle here. Now let's look at an example. What we want to do is use a half number identity to find an exact value for this guy here. So what we'll do is we'll rewrite this guy. We have sine of 3 pi over 8. Now we'll rewrite this as sine of 3 pi over 4 times 1/2. This is going to be the same thing as 3 pi over 8. And in this case, we can rewrite this guy as a half angle. We'll have 3 pi over 4 divided by 2. And in this case, our angle A then will be 3 pi over 4. And what we want to do is evaluate sine of A over 2, or 3 pi over 4 divided by 2. So we'll use this identity here. We also know that 3 pi over 4 is going to be in the second quadrant. And in the second quadrant, our value for sine is always going to be positive. So we're going to take the positive of this square root. So we have 1 minus cosine over angle A divided by 2. Now, evaluating this, cosine of 3 pi over 4 is going to be negative root 2 over 2. And this is still over 2. So this gives us the square root of 1 plus square root 2 over 2. Still over 2. Now adding these guys, we have 1 plus square root 2 over 2. So that's the same thing as 2 over 2 plus square root 2 over 2. So this gives us the square root of 2 plus the square root of 2 over 2. And this is still all over 2 under the square root. Alright, now we'll simplify this a little bit more. This is the same thing as 2 plus the square root of 2 over 2 times 1/2, since we're dividing this whole thing by 2 here. This gives us the square root of 2 plus the square root of 2 over 4. And then in this case here, this will be the square root of 2 plus the square root of 2 all over the square root of 4, which we know is equal to 2. So this will give us the square root of 2 plus the square root of 2 all over 2. So 2 is not under our square root. So this will be the exact value for sine of this angle here. Alright, let's look at our last example. we want to do the same thing. We're going to use a half number identity to find an exact value for this guy. So we'll do the same thing in rewriting this angle. So we have tangent of pi over 8. This is the same thing as tangent of pi over 4 times 1/2. And this is the same thing as tangent of pi over 4 divided by 2. So in this case here, our angle A is going to be pi over 4. So we're going to do the same thing here. We're going to use the identity for tangent. So that'll be this guy here. We'll use 1 minus cosine of A over sine of A. We could also use this guy or this guy, but these two might result in more complicated calculations. So, like I said, we'll use the other identity. So this will be cosine of our angle A all over sine of our angle A. We know that cosine of pi over 4 is going to be square root 2 over 2. And we know that sine of pi over 4 is going to be the square root of 2 over 2. Now what we want to do is simplify this. We'll rewrite this numerator to have a common denominator so we can subtract them. So we'll get 2 over 2 minus square root of 2 over 2. And this is still all over the square root of 2 over 2. Now this is going to be the same as 2 minus the square root of 2 all over 2 in our numerator. And since we're dividing by the square root of 2 over 2, what we can do is multiply this by the reciprocal of that. So that'll be 2 over square root of 2. Now these guys here will cancel. So we're left with 2 minus the square root of 2 over the square root of 2. And like I said, we always want to rationalize our denominator. So we'll multiply the top and bottom by root 2 over 2. Doing so, this will give us 2 root 2 minus the square root of 4 in the numerator. Just multiplying this to both terms here. All over the square root of 2 times the square root of 2, which is the square root of 4. This will give us 2 square root of 2 minus 2 all over 2. And then this 2 here is dividing this term and this term, so these 2's and these 2's will cancel. So we're just left with the square root of 2 minus 1. And so this will be our exact value. This will be our exact value for tangent of this angle here. Alright, so that'll be it for this video.